Hello everybody. This time in this lesson I would like us to look at vectors in 2 dimensions, and I'll start off by defining what a vector is. A vector is a quantity that has magnitude and direction. So it has both size or magnitude and also direction. An example of a vector is here given as velocity. There are so many examples that we can give, but velocity is one of them. Normally we give direction for velocity and also magnitude. And so magnitude, we are going to look at some questions that can help us to calculate the magnitude of a given vector. So here we are going to use column vectors. These column vectors to calculate the magnitude of these column vectors. So in this lesson, I want you to understand how to calculate the magnitude of a column vector. So in our first question, the question says calculate the magnitude of the vector AB, which is given by 3 and 4. So it's a column matrix or column vector. So we'll look at the solutions. Okay, we are going to look at the solutions, and in our first question we have AB, the vector AB. So as you can see on top here, we have an arrow pointing in the direction of the vector. So this gives us the direction, and so this is given by 3 and 4. Okay, so the formula that we use for calculating the magnitude of a vector is given by magnitude of the vector AB in this case. Okay, so these lines that you are seeing, they signify magnitude. So this is equal to the square root of x squared plus y squared. Okay, so where in our question here x is the number 3, so this is our x, and 4 is our y. So we are going to substitute in this formula that we have here. So we are going to have 3 squared plus 4 squared, and this is going to give us the square root of 3 squared is 9. It's 3 times 3 plus 4 times 4, which is 16, and then this is going to give us the square root of 25 when we add under the square root sign. And so the square root of 25 is actually 5 units. And so this is the magnitude or the length of our vector. It's 5 units. So that's in our first question. And then now we can go to our second question. Our second question says given that OA is equal to -1 and 5. So in our second question we are given that OA is equal to -1 and 5. Okay, and then we are also given the coordinate for B. B has the coordinate 2, 7. Okay, so I'm going to show you also how to write a coordinate as a vector. So here is B. I'm going to write it as a position vector. So the position vector for the coordinate B is OB. So position vectors are vectors that begin from the origin O. So this coordinate B 2, 7 can be written as a position vector, which is OB is equal to 2 and 7. 2 and 7. So we have written B as a vector. So the first thing that we do in this question is to find the vector AB. And so the vector AB is found by this formula. So we say AB is equal to, the vector AB is equal to the vector AB is equal to OB minus OA. Okay, so this is a formula that we get under position vectors. So when you are trying to find the vector AB, when you have OA and OB, all you do is you subtract OB minus OA, and so this is going to give us OB is 2 and 7 minus OA is that one there, -1 and 5. And so we are going to subtract here. So we are going to have 2 minus -1. So we subtract this 2 minus that -1, and 7 minus 5. So this is going to give us, here these two negatives will give us a plus, so it will be 2 plus 1, which is 3, and then 7 minus 5 will give us a 2. Okay, so this is our vector AB. And now the question says calculate the magnitude of the vector AB. So the magnitude of AB is given by the same formula, square root of x squared plus y squared. So which will give us the square root of 3 squared plus 2 squared. Okay, so this is going to give us the square root of 9 plus 4, which will further give us the square root of 13. Okay, so this is our answer. You can still simplify this by using a calculator, but you can also leave the answer as the root of 13 units. So you can end here, or you can find the square root of 13. So thank you very much for paying attention.